All right, Whitney. So looking at this problem, I think the key thing, this is number 51, is we are interested in x as the number of years after 2000. So if our ordered pair is 7 and 32, then our x value, what that actually tells us is that we're in the year 2007 because that 7 is the number of years after 2000. So the first part of the explanation is in 2007. Okay, the other important part of the explanation is that our y value is the number of joggers in millions. So what this means is that we have there are actually 32 million joggers. Okay, so and this is really common thing for us to do when we're dealing with any kind of a businessy kind of question. We generally don't want to plug 4-digit numbers into our x coordinates and the equations that we get. So a lot of times what we'll do is make the first year that we're interested in the year 0, and then we're working with single-digit x values instead of 4-digit x values. So that's what this one stands for. The 7 in the x position tells us that we're in the year 2007, 7 years after 2000. The 32 in the y position says that there are 32 million joggers. Okay, the last part there, it says if this trend continues, how many joggers will there be in 2018? What you want to ask yourself here is how many years after 2000 is 2018? And so that's going to make our x equal to 18, and we're going to take that value, plug it in for x in our equation, and then work it out. So that should get you to the answer to part C. Okay, so the scale is the key on this problem. X is the number of years after 2000. Okay, hopefully that clears that one up. All right, so for number 23, we're graphing y equals 3x plus 4. I kind of don't like this problem being in this section because we're going to learn a much simpler way to graph this equation very soon, a little later in the module. But for right now, we're limited in our options, so we're just going to make an xy table and we're going to fill it in. There's an easier method to graph this for sure that we'll learn a little later though. But for this particular problem, what I'm going to do is I'm just going to pick some values and I'm going to plug them in for x. Since the y is already solved for, the y is by itself on one side, I don't want to plug in values over there. I'll probably get fractions. But if I just pick different values for x, I should be okay. I should be able to avoid those fractions. So I'm just going to pick a couple of values like maybe 0 and 1 to plug in for x. Okay, so if I do that, I'll start with the 0. I'll get y is equal to 3 times 0 plus 4. Working that out, I'll get y is equal to 4. And so 0, 4 is going to be a point that I'm going to use to graph this line. Next, I'll plug that y in. So I'll have y equals 3 times 1 plus 4, which is 3 plus 4, or 7. So 1 and 7 will be a point on my graph. And that's really all we need to graph a line on MyMathLab is 2 points. It doesn't hurt to have a third point as a checkpoint, but it's not a required part of the process here. So what you'd want to do next is just go to your graph on MyMathLab, click on your line tool, which is kind of the middle button at the top of your template on the right-hand side, and then you want to go and you want to select 0, 4 and plot your first point there, and then you'll want to slide your mouse over to 1 and 7, your second point there. It should connect those points up for you automatically, and you should get your line on your graph, and that's what we're looking for. I can use other points, but again, keep it simple. Choose x values for just choose x values here since we're already solved for y, and then pick easy to work with numbers, maybe 0, 1, -1, maybe 2. Don't make it any harder than you need to. Okay, so hopefully that's enough to get you started on those two problems. Please let me know if you have any other questions.